This is just an educated guess, but I really believe they will have a differential equation, a problem where you have to solve a differential equation on this year's test. They've had one on every AP test for many, many years. This is a problem that you can't really solve with a calculator, so they like it because they know you can use your calculator, but they want to give you something that you can't use your calculator on. So I'm pretty sure they'll have one like this. Use the SASE method for sure. So I start with the differential equation, dy dx. First thing I do is multiply the dx across. I'm going to move the y cubed, so I'll end up with 1 over y cubed. I can't take the antiderivative of 1 over y cubed, so I move it to the numerator. Now I can take the antiderivative. If you get to this point, if you have this purple line, they will give you 1 point for correctly separating. To take the antiderivative, you can look at your golden notes. This is going to become y to the negative 3 plus 1 divided by negative 3 plus 1. This becomes x squared over 2. And then we have a constant. If you get that far, they will give you 1 more point. Next thing is to find the c, so it's the SASE method. So we've got separate, anti-differentiate, and then constantate. So here's my initial condition. So when x is 1, y is 2. This is going to become, I don't like negative exponents. So this is y to the negative 2 divided by negative 2. This is x squared over 2 plus a constant. The negative 2 cannot change, so this is going to become 1 over negative 2, or negative 1/2. This will become 1 over y squared. So now I can plug in the values to find c. So I have negative 1/2, 1 all over. The y value is 2. The x value is 1. I always use parentheses when replacing variables. So 2 squared is 4. So this is going to be negative 1/8 equals 1/2 plus c. Therefore, c will equal negative 1/8 minus 1/2. And you can leave it like that. If you have this statement right here in red, where you plugged in the initial condition correctly, that's a really bad arrow. So if you have this statement right here in red, that's 1 point. If you go on to find the value of c, you don't have to simplify again, remember, that's another point. You can leave c like that. We're going to change it just because it makes the next writing a little bit easier. So negative 1/8 and negative 4/8, that's negative 5/8. Now I have to go back to the equation, which was here. So I have negative 1/2 y squared equals 1/2 x squared. Constant is minus 5/8. Now I have to isolate the y. So I'll multiply both sides by negative 2. That means the negative 2 has to distribute here and here. So I'm going to get y squared equals negative 2 times this. These will divide out. I'll get negative 1 x squared. Negative times negative is positive. The 2 and the 8 will divide to make 1 over 4. So this will be plus 5/4, like that. And apologies, I noticed a mistake. This was not y squared, it was 1 over y squared. Which means this is still 1 over y squared. If I multiply both sides by y squared and then divide both sides by this, I'm going to end up with y squared is equal to 1 over negative x squared plus 5/4. And then the last thing to do is to take the square root of both sides. When you're finding a square root, though, you must consider both the positive and negative solutions. However, I'm supposed to be able to plug in a 1 and get a positive 2. So I'm going to have to be using only the positive solution, so I don't have to worry about the negative. And if I get this final answer here, that's one more point.